name's Ryan Kilmer, physics student. Alright, and we got a physics problem here today. Alright, we got a sweet drawing of the word physics. And, this problem's dealing with like acceleration, displacement, all the fun stuff about physics, all like the key core things about it. Alright, so let's throw up a new thing. And let's start the problem here. Magic. Alright. So the problem right here is asking a 2008 Mercury Mariner, possibly my car, is traveling at 15 meters per second on a highway. Alright, and there's our highway. During the journey, a giant asteroid. Oh, what? Wow, I'm almost forgetting something. The sweet car. Oh boy. Alright, with this sweet car. Alright, and during this journey, a giant asteroid lands about this big thing going on there. It's a giant asteroid with some fire on it. Is landing 50 meters in front of the car. Alright, so this little jerk dude is landing right here, right there in the middle of this guy's drive. Alright, and he's landing 50 meters in front. And so the car can only come to a complete stop in 7.6 seconds. So this is the car traveling at 50 meters per second and coming to a safe, not like slamming the brakes kind of stop. And stops at 7.6 seconds. So it says calculate the acceleration of the car and also calculate if the car will hit the asteroid or not. If the car hits the asteroid, how much time would the car have needed to stop so that it would not hit the asteroid? Sorry, hiccups. So first things first, let's throw down all the important information, like our final velocity, which was 0 because it came to a complete stop. It's obviously 0. Our initial velocity is 15 meters per second, because that's how fast the sweet dude was driving on the highway. The time is 7.6 seconds. And we do not. Oh, I don't know what I did. Our acceleration, we do not know yet, and our displacement, we do not know yet. So let's jump right into it. The acceleration equation is acceleration equals final velocity, which is 0, minus the initial velocity, which is 15, all over 7.6, which is our time. Crunch the numbers, do the math. Comes out to negative 1.9 meters per second squared. The cool part about this, though, is, let's grab a different color. This negative right here, it's because this car is actually slowing down and coming to a stop. It's the change of acceleration is the change over velocity, basically the rate of change of velocity. And because the velocity is going from 15 to 0, it's actually a negative. So it's pretty cool. I don't know. I love physics, so I think that's pretty sweet. So you get a negative acceleration. So then we'll use that to find our actual distance that it stopped. So to find the distance, the displacement I meant to say, it's x equals, and this represents displacement, x equals 15, the initial velocity, times time, which is 7.6, plus the 0.5 times the acceleration, which is negative 1.9, times the time squared, which is 7.6 squared. Alright, throw this in your calculator, do your math skills. We're in physics, we should all be pretty proficient in math here, and you end up getting 59.13 meters. Now there is an issue with this because this asteroid landed 50 meters in front of said car, in front of this awesome sweet car we know, with this sweet muscular dude driving the car. Alright, so the issue is because he went an extra 9.13 meters and couldn't stop in time. He just basically crumbled into this awesome ball of just car, and just was just done. So we are not done with this. Then we can't just end it with leaving this dude all crushed up in a ball next to an asteroid. Second part of the question, because it says, will the car hit the asteroid or not? If the car does hit the asteroid, which it did, how much time would the car have needed to stop so that it would not have hit the asteroid? Let me tell you, folks, it's not over. Alright, it is not over. Let me just throw this in here because, you know, let's stay neat and let's look really organized with this awesome computer screen handwriting. So we're actually going to switch it up a bit. We're actually going to take out, different color, that kind of sticks out. We're going to take this and we're going to plug in this 50 meters right there. Alright, and then the time, you're going to get rid of both of those, and we're actually going to put in a variable of t to represent time. So let's bring it all back now, and we'll do 50 equals, and this is actually because we're showing the distance, and we want to find how much time he going, you know, him like just this guy ripping the e-brake, you know, how much time would he need to stop, you know, before he would hit it. And I'll tell you, it is going to come out to, you know, the car kissing the asteroid, but I tell you, it doesn't crumble up into a ball, so that sounds like a win to me. So 50 equals, and everything else is the same. So 15 for the initial velocity times t plus 0.5 times negative 1.9 times t squared. Now, you're looking at this too, and you're like, dang, that's going to come out to a quadratic equation, which really, it breaks your heart sometimes. So, and it's going to come out to negative 0.95 t squared plus 15 minus 50. Now, you could use your math skills and, you know, do all that sweet, you know, like this and pull out some numbers and, yeah, no, we don't do that here. We're going to go the easy way, take said numbers and plug them into a quadratic formula equationator, alright? Go to math.com, Google it, it's on here. You know, shout out to these dudes because they make my life easy. Alright, so we plug in the A, the B, and the C, plug them all in, hit solve, and look at that, we got 2 answers right there. It's a pretty sweet deal. Alright, now if we use our common sense here, alright, we use our common sense here, and as you can see, there's an 11 and there's a 4. Alright, the car hits the asteroid in 7.6 seconds. So any number that's greater than 7.6, you're gonna just crumble into the asteroid again. And don't get me wrong, these are both correct answers, but we want to look for the one that's gonna work for us. So 4.78 is looking smaller, is looking better. So 4.78 seconds is looking pretty sweet because you won't hit the car. Instead, you'll actually be doing this with the car. So it is not black, it's red. Alright, so we got the sweet car. I swear the car gets better and better every video I do. Alright, the sweet car, and it's gonna literally stop nose to nose kissing this asteroid. Alright, but the car's not totaled, and the little dude inside is all safe because he ripped the e-brake and saved his, you know, his 2008 Mercury Mariner. So, sweet deal to me. So that was physics. That was our physics problem. I hope you learned something. Take this home with you. Put it in your real life. You know, live it, learn it, love it. And now we'll figure out how to turn this off. Haha. Alright. Good looks, my dudes.